If your existing or proposed building contains renewable electricity, you can model solar PV or even wind in the PV module. Let's add a PV system. We'll give it a title. We'll add it to scenario 1. It's a proposed system. There's no existing renewable electricity system in this building. We'll install a 5,000 watt system. The kilowatt hour over watt factor, kWh over W, ignore the typo, is an estimate of how many kilowatt hours the system will produce for every watt that's installed on an annual basis. You can look up information for your region at the PV Watts website. I'll use 1.1, which means we'll produce 5,000 times 1.1 equals 5,500 kilowatt hours per year. We have a $20,000 installation cost. Maintenance is estimated to be about $100 a year. We have a state incentive of $500 on this system, a federal incentive of $6,300. No additional incentives, but you could put something in here if your utility or other entity offers an incentive. You may have a production credit or feed-in tariff. In this case, we'll enter 10 cents for every kilowatt hour produced. Save your system. To model a wind electric system, enter the peak watts here and enter your capacity factor here. We've landed back at the PV page now, where we can take a look at the PV system we just modeled. The values we entered have carried through to the system table. Energy contribution has been calculated. This means that our annual power production is 57% of the total household electricity use. Our costs and maintenance, along with cost to install, price per watt, incentives, production credit. The net installation cost is the total cost minus the incentives. The price per watt after figuring in the incentives. The annual value of the energy produced by the PV system is based on the cost per kilowatt hour your utility charges you and the feed-in tariff that you entered earlier, and a conversion of electricity to millions of BTUs. Looking at the scenario evaluation, again we see similar numbers. If we had more than one renewable energy system, they would all be included here. The lifetime value of energy produced is the annual value times the lifetime that was entered earlier, and includes the effects of energy cost escalation. A negative value for cost to own and operate indicates that you're actually making money. Both annual and lifetime values have been calculated. Annual energy savings, lifetime energy savings, the lifetime value of the systems, simple payback, cost per million BTUs, your benefit cost ratio, return on investment. With the installed PV system, our annual electric costs will be reduced to just under $53 per year. And your lifetime electric utility costs. The lifetime cost to buy PV generated power includes the net installation, or the cost of the system after subtracting out all the incentives, plus the maintenance costs over the system life. This figure is divided by the kilowatt hours produced over the lifetime of the system. Another way to think about this is to consider the average cost of a kilowatt hour supplied to you by your utility over the next 20 years. If the lifetime cost to buy a kilowatt hour of PV generated electricity is less than the cost of a kilowatt hour purchased from your electric company, then this system is a financial benefit to you. This figure does not include the value of any feed-in tariff that you may have entered. The average annualized value of power produced is the dollar value of all the energy produced over the life of your PV system divided by the lifetime kilowatt hours produced. This figure does include the value of the feed-in tariff that you may have entered. And that's all there is to add renewable energy systems to your project.